application of differential equation in physics. In mathematics, the relationship between physical motion and its rule of changing can be described with a function. Sometimes, it's hard to find the function that corresponds to the fact directly for the actual problem, but it's easy to establish the relation between these variables and their derivatives. In this case, the application of differential equation can perform its mathematical advantage in many disciplines. For example, the differential equation is really useful for measuring the object without some missing conditions. Here is an example. Suppose a bullet shoots vertically from left to right into a 20 centimeters plane with the velocity 500 meters per second and falls out with the velocity 100 meters per second. Suppose the resistance to the bullet's movement is proportional to the square of its speed. The force from left to right is positive, and the force from right to left is negative. The question is how long the bullet passes through the plant. Here is a picture can help you guys to understand this question easily.
The fixed formula applied in this question is the net force, the drag force, and in this question, the question gives us that the resistance to the bullet's movement is proportional to the square of its speed. So we create a new drag force to this question. And suppose xt is the thickness of the plate. T is the time that the bullet passes through the plate. Since x is the thickness of the plate, then the second derivative is the acceleration and the first derivative is the velocity. So we can plug the velocity and the acceleration into this equation. Then we set a new variable p equal to the first derivative of x and create a new formula. Move m to left to the right and move dt to the right. Then we can add the integral to both sides and solve these two integrals. We can get this formula. Then we need to calculate the constant c. When t equal to 0, p is equal to the initial velocity, which means c is equal to 1 over the initial velocity. Then we can plug the constant back to the equation. Then we can get the equation for the p. We continue solve the formula. We move dt to the right and add the integral to both sides and solve these two integrals. Then I can get a new formula for x. We continue solving the constant c0. Because the bullet does not move at the origin when t equal to 0, x0 equal to 0. So we can set this equation equal to 0 when t equal to 0. After solving this equation, we can find the constant c0 equal to m divided by k long v0. Plug c0 into the equation and we can get the formula for x. And we simplify the x. We can get equal to 20. It means that the bullet passes through the plate and keeps the velocity 100 meters per second. So we can find p equal to v1 and get a formula for v1. And simplify this formula, we can get a new equation that relate to the t. We plug back to this formula, and we can get xt equal to this equation, and simplify this, we can get xt equal to m divided by k ln v0 divided by v1. So we can find constant m divided by k is equal to this equation. And finally, we can find the formula for t, which is this one. And we plug in the variable gives in question, and we can get the final solution. And we can get t is equal to 9.941 times 10 negative 2.
Now is the conclusion. Differential equation can help us express many missing conditions. We can reuse this equation when the variables of these three conditions change. The advantages of the mathematical model established by the differential equation can be seen clearly. The extent of differential equation is to solve difficult problems in practical life with the aid of differential equations. In the process of solving the problem, differential equations and mathematical models were used to combine the reality of life with the mathematical theory, skillfully transforming the actual problems into mathematical problems and simplifying the way to solve the problems. Here is a reference. Thank you.